Hello everyone, hope you are doing well. On behalf of IEV Technologies, we are excited to have you with us as we deep dive into the most significant shifts in modern history, which is the global transition to electric vehicles. Whether you're here to learn for your career or preparing for your first EV purchase, IEV Technologies is here to guide you through the tech. Let's get started. For a long time, electric vehicles were seen as a niche market, a curiosity for the few. But today, that has changed. We are witnessing a fundamental shift in global mobility, one that is no longer a possibility for the future, but a reality on our roads right now. This isn't just about changing what's under the hood. It's about a global move towards clean energy and advanced engineering. At IEV Technologies, we believe that understanding the transition to EVs is the key to understanding the next century of transportation. From the way our cities breathe to the way we power our homes, everything is evolving. With that saying, let's start the discussion by keeping this question. What are electric vehicles? Electric vehicles use electricity as their primary power source, replacing the traditional internal combustion engine. EVs are propelled by electric motors drawing energy from batteries. Crucially, EVs produce zero tailpipe emissions, supporting global decarbonization. Believe it or not, EVs aren't a new invention, they are a comeback story. We have actually come full circle returning to a technology that dominated the roads over a century ago. Let's deep dive into the history of electric vehicles. The first thing, the Victorian Golden Age, 1830s to 1910. In the early 1830s, Robert Anderson built the first crude electric carriage. By 1900, EVs were the preferred choice, accounting for one third of all cars. They were quiet, clean, and did not need a dangerous hand crank. Cheap oil, the expansion of highways, and the affordable Henry Ford Model T eventually pushed electric cars off the road. The Modern Revival, GM EV1 1996. After decades of silence, GM launched the EV1, the first modern purpose-built EV. Despite a cult following, GM recalled and crushed the fleet. This death of the EV1 directly inspired the creation of Tesla. The performance shift, Tesla Roadster, 2008. Tesla proved EVs weren't just golf carts. The Roadster was fast, 0 to 60 in 3.7 seconds, and long range, 200 plus miles. It turned the electric car into a high-tech luxury item that people actually wanted to drive. Mass market adoption. It's no longer about if the car works, but how fast we can grow the global charging network. With knowing the EV history, let's dive into the key internal components of an EV. An EV often has just few moving parts compared to huge number of parts in a traditional engine. The core components are the battery pack, the electric motor, and the inverter. The efficiency of an EV relies on a seamless flow of energy through three primary systems, and let's talk about them one by one. The battery pack. This is the fuel tank of the car, typically consisting of thousands of lithium-ion cells. It stores energy as direct current. The electric motor. Unlike an engine that uses exploding fuel to push pistons up and down, the motor uses magnetism to create rotation directly. This provides instant torque, allowing for rapid acceleration without the need for a multi-speed transmission. The inverter. Since most EV motors runs on alternating current, the inverter acts as the translator. It converts the battery's DC into AC and manages the motor speed and torque by adjusting the frequency and timing of the electricity. Now let's look at the different type of EVs. There are three types of EVs: battery electric vehicles or BEVs, plug-in hybrids, and hybrid electric vehicles. Battery electric vehicles or BEVs are 100% electric with zero emissions. BEVs are best for those who can charge at home or work. With modern ranges now averaging 300 miles, these are now fully capable of long road trip thanks to high-speed charging networks. Plug-in hybrids. PHEVs combine a battery and an engine. PHEVs acts as the bridge vehicle, ideal for people with a short commute, which can be done on 100% electric, but who occasionally drive 500 plus miles in a day where charging might be sparse. Hybrid electric vehicles HEVs self-charge via braking but cannot be plugged in. So, HEVs are best for those who cannot charge at home but still want to reduce fuel costs and emissions significantly compared to a standard gas car. Comparing EVs and internal combustion engines shows major differences. EVs perform with 85% to 90% energy efficiency and low maintenance needs. Their operating costs are also significantly lower at about 4 cents per mile. Key benefits for modern owners include a lower total cost due to savings on fuel and maintenance. They also offer instant performance, silent operation, and a direct contribution to reducing one's carbon footprint. With the aforementioned benefits, EVs also offer significant environmental impact reductions. On average, they result in 50% lower lifetime CO2 emissions compared to gasoline vehicles, even including manufacturing and grid power. The charging infrastructure is rapidly expanding. High power level 3 DC chargers can now add 200 miles of range in under 15 minutes, which is helping to eliminate range anxiety for long distance travel. Current industry challenges include ensuring the sustainable supply of critical minerals, addressing the higher upfront cost of batteries, and managing the electrical grid load. Now let's go through it one by one. The first one is solving the supply chain problem. The move to electric isn't without its hurdles. Sourcing critical minerals like lithium sustainably is priority number one. In 2025, the industry is shifting towards direct lithium extraction, a method that uses 90% less land and water than traditional mining, and closed loop recycling that covers up to 95% of materials from old batteries. Moving to the next one, which is the cost of admission or the upfront cost. While batteries have historically been the most expensive part of the car, costs have dropped to roughly $130 per kilowatt hour. With new chemistries like sodium ion and lithium ion phosphate entering the mainstream, we are finally reaching the tipping point where an EV costs the same upfront as a gas car. And finally, the last challenge, that is supporting the grid. The question that comes is that can the grid handle peak loading? The smart answer is yes, and the reason behind saying yes is smart charging methods. Modern systems now balance the load by shifting charging to off-peak hours when the demand is low. Some EVs even act as giant backup batteries for our homes through vehicle to grid tech, actually making the electrical grid more stable, not the less. As we reach the final part of our discussion today, it's the time to zoom out and look at the bigger picture. Understanding where the technology is going requires us to look at the global stage. To do that, we are referencing the following figure. The figure we are about to analyze comes from the Global EV Outlook 2024 published by the International Energy Agency IEA. The IEA outlines three primary scenarios in its report: the stated policy scenarios, the announced pledges scenarios, and the net zero emissions by 2050 scenario. The stated policy scenario under the STVPS, which considers existing policies and measures, the global stock of electrical vehicles, excluding two or three wheelers, is expected to rise from under 45 million in 2023 to 525 million in 2035. This represents a 23% annual growth rate, suggesting that 1 in 4 vehicles on the road would be electric by 2035. Net zero emissions by 2050 scenario. The most ambitious, the NZE scenario, aligns with the global target of limiting temperature rise to 1.5 degrees centigrade. It projects a rapid increase in EV adoption, with the fleet growing at an average annual rate of 27%, resulting in nearly 790 million EVs by 2035. So with this, we come to the end of the video. Thank you for joining and listening to IEV Technologies. If you found this session valuable, please hit the like button and subscribe to stay updated on the electric vehicle technologies. For a deeper dive into the information we discussed today, check out the links in the description below. And if you are interested in learning more about electric vehicle technologies, please do reach out to us either by commenting in this video or by sending out an email or via through our LinkedIn page IEV Technologies. The future is electric. We'll see you on the road.